Okay, so before we close off this semester, I want to try to give you a super brief upshot of what we've learned here this fall. So remember, I started off by telling you that language is fundamentally a connection between form and meaning, and the form can take on many different kinds. So it can be speech, it can be the written form that we read, it can be sign. Turns out that no matter how you enter the language system, which kind of externalization you use, the neural substrates of language turn out to be pretty similar across the different modalities. So now I want to try to summarize the processing stages and what we've learned about the neural basis of those processing stages kind of on just a single timeline for one modality. And I'll choose the written modality. So this will be comprehension as you're reading, simply because that's the modality that I personally understand the best. And it is also the modality that has been used the most in cognitive neuroscience experiments, simply because it is just kind of methodologically easiest for us to handle. So it's kind of a pragmatic reason for that. Okay, so here's your brain, and here's your visual stimulus cat. Got to stay faithful to our favorite word. And let's assume that that word is in a combinatoric context, so you're reading it in the middle of some expression. How does your brain handle this stimulus? Well, we've learned about the visual word form area, so that's in the left hemisphere in your fusiform gyrus. So at this stage, and when we measure the time course of this activity, it peaks around 170 milliseconds. We find that your brain seems to be separating between visual word forms and letters as opposed to other types of visual stimuli. So that's kind of where uncontroversially the sensitivity to the visual stimulus starts. And when I say uncontroversially, I mean that everyone agrees that by this time it has started. It might even start earlier. What happens next? Well, obviously the task in comprehension is to map this form to meaning. That's what we just said. And we think that the kind of hub for connecting form and meaning very much lies in the temporal cortex, kind of in middle to posterior temporal cortex. And that is sort of the center of lexical access effects as evidenced by lots of different types of experiments. So most models will have some kind of a form to meaning interface for lexical items in this general region. And when we again measure the time course with a technique like magnetoencephalography that has the millisecond time resolution, the effects are temporally located around 300 to 400 milliseconds. So that's kind of the center for gravity for those types of lexical semantic effects. So there's, of course, much more that you would want to add to a full theory of lexical access, but I want you to kind of take away these two generalizations. So now I told you to imagine that our word is in a combinatoric context. What have we learned about the integration processes of a word to its combinatoric context? Well, I've told you about the left anterior temporal lobe. And in this region, in a relatively early time window, so actually kind of lands between the visual word form effects and the really meaty lexical semantic effects around 300 to 400 milliseconds, we already see some evidence of semantic combinatory effects. So that already tells us that hypothesis that lexical access happens around 300 to 400 milliseconds is not going to be the full story. So actually, it seems to be the case that when we're composing meaning in a context, there is enough meaning available already around 200 milliseconds that we can start to combine concepts, at least in certain situations. And we talked a little bit about the limits of this type of quick conceptual combination. We already also learned that a little bit later, there's a prefrontal kind of hub that also shows semantic combinatory effects. So now in comprehension, especially in particular in the written modality, around 400 milliseconds, the ventromedial prefrontal cortex also shows an increased signal when you're composing structure. And so now that leaves syntactic composition, so the creation of those more complex phrase markers, a little bit mysterious. I briefly mentioned that the posterior temporal lobe, again, we're in the left hemisphere, is emerging as a possible syntactic hub. And so this is a hypothesis that we can kind of see how it develops and becomes more detailed in future years. I've put it early in the timeline because of results from my own lab where we've seen this kind of activation basically happening in parallel with the left anterior temporal lobe activation. And of course, when we started talking about syntax, we started by talking about the LIFG, aka Broca's area. And we started by discussing classic hemodynamic findings that show us that it is sensitive to long distance dependencies. We've measured those types of effects in MEG as well. And what we've found is that the LIFG effects of long distance dependencies land in this kind of mid latency time window between like 250 milliseconds and 400 milliseconds, approximately, depending a little bit on the kind of construction that you're looking at. So what we see here is that a picture is emerging in which basically between 200 milliseconds and 400 milliseconds, it's a very small amount of time, there is a very complex set of processes that happen that both access and represent word meanings and then perform all the various types of computations that are required in order to actually integrate that word into its broader context. And here I just have a very, very small subset of those processes included. So it's bye for now. Follow this channel if you are interested in updates. I probably will be using the channel in my future classes as well.